Hey, so this entire Linux series is going to be like really specific. I've been working on Linux based operating systems since 2013. I've done, multiple modifications in binaries. I've done, customization in my own, Android operating system, which is also a Linux based operating system. So I've done so many things over this period of time. It's been around like 2000, it's been since 2013. It's like 10 years now, so it's more than 9 years, like, oh yeah. So I've done so many things. I have been, working, coding, programming, exploring things, getting stuck in terminals by, some programs just got stuck into terminal. They just acquired, not being able to process them, then, tackling them, getting stuck for like 2 to 3 days sometimes in a problem. So over this period of time, I've learned so many things, and hopefully this entire series also going to be, showing you those problems without editing out all those things, because on the my always, focus remains is on, trying to solve the problem and trying to, tackling the problem more, so that you could learn actually in that process. And that's always been my learning pattern. So I'm also, not gonna edit out too many things. We're gonna see problems also. We are going to work together. I've designed this like around currently with 4 modules, with having few projects into it, like tiny projects, so that we can work with files, we can work with, you know going to understand like how certain files privileges could be changed. We're gonna also see that how to work out with shell. So there are a lot of things, and we're not going to, spend so many time like bogusly, which is not gonna even make sense. But what we are gonna do is, we are going to learn in a way that we could remember it for like a really long time. We could like have an idea like, okay, so, so this file is there, so that might be the possibility of it, or that could be a possible command, so that we can work. For example, I remember one of my friend just asked me that they just got a problem that they want to read the, they just want to abruptly stop the program while it is reading from the terminal, and if anyone presses any character other than the English alphabets, it just need to be stopped immediately. So my initial thought just went is, since everything is a file in Linux, which we're gonna see why, what we can do is to, just read the buffer. Well, what buffer is, I'm also going to explain, but buffer is kind of like, the stream, the input which is being sent. So we just have to continuously monitor that stream, and if any character besides the alphabet scheme, we'll just have to stop. So these sort of approaches which I have taken, learned, and will see in this entire course of series. Bye. So the basic requirement for, installing a virtual machine on our Windows operating system is gonna be something like that. We kind of need an operating system. Windows could be about Windows 10, and Windows 10 could work, and maybe Windows 7 also works. There's no problem with that. But what is requirement is the 4 GB of minimum RAM. At least it should be there. Mine current PC is having like around 8 GBs of RAM, so that will be sufficient. But 4 GB could work. There is no problem with that. And at least of 100 GB of space, but you don't need that much of space. But at least you should have at least around 100 GB of space in your machine. It could also work fine with around 30 to 40 GBs of space, so there is no problem with that too. So the first thing which we have to do is to go to your any search engine, whichever you like, and all you have to do is to go and search about download VirtualBox, and over there you have to hop to the link virtualbox.org. You can also directly type this link virtualbox.org, hit it, and at the very first page you're going to have some options regarding that which virtual boxes you're gonna need to download. So for in this case, since we're using Windows operating system, what we're gonna do is we're going to hit the Windows hosts, and it will eventually start the download. I already have downloaded it, so there is nothing much to worry about. So it's already been downloaded. Now the second thing is we have to go to download the operating system itself, and for this case right now, right here, we're downloading Ubuntu. You can use CentOS or any other Linux based operating system. It's all up to you, but here we're downloading Ubuntu, And here we're gonna download LTS, long-term support. You can also select any other desktop version of the images which you if you want, but for the purpose, for the sake of the learning and for not getting into troubles, well, usually it generally doesn't happen, but it's better to stick with the LTS part. So just hit the download button. It will lead you to another page where it says thank you for downloading, and eventually I think the download will start within a fractions of second. So I already have downloaded it, so we're not gonna waste our time here to wait for it. So getting started with downloading, gonna just hit the back. I don't know whether the call has been made or not. So once you install VirtualBox, it's quite a relatively easy process. There is no problem with that. Let me stop this downloading right here. It does it We don't even need that. So after installing the VirtualBox manager, it's quite easy. You don't have to do anything, just have to hit some next buttons, and like relatively easy. So after that, what we have to do is to create a new VirtualBox, and for that we have to hit the new button right here. Now here you can name it anything you want so that you can remember, because in virtual boxes we can have like multiple virtual machines. And here we're gonna create our first virtual machine, and it's gonna name be like Ubuntu English. I'm just naming it anything. You can name it anything you want. And now here it's the location where it's been gonna created, and here the ISO image that you have to select. So just hit this arrow button and just select others. You can go and select whichever the ISO you want. So we want Ubuntu because we have to work on the Ubuntu operating system, and here it is. Now just select next. You don't have to do much. Oh, okay, so I already have one folder. Wait, okay. Oh, I already have created one. Gonna have to change this to others. Now here I'm gonna create a new, maybe I'm gonna delete the old one. It will be much better. Yeah, select the folder. So it's gonna create a new folder. It would be like a fresh start. Yeah. Oh yeah, it's working. So okay, so now here with the username, you can select any username you want, and with the password, like remember you have to change the password so that you can use it, or the other person could not have the higher privileges. So we'll talk about the privileges, but it's like a security measure you should take and you should consider. So I'm gonna name it myself, and with password I'm gonna leave it as it is for now for the sake of this video, but you can change it. There's nothing harm in that. Here's a host name, and it's just a domain name, so it's just so that the internet should get connected with our virtual box in eventually in the virtual machine. All you have to do then, here you can like assign a little bit more RAM, because I have around 8 gigs of RAM. So I'm gonna stick with inside this green zone, so that I won't having any other performance issue on my main host machine. And you can increase the CPUs custom. I'm giving it like 2 CPUs right now. It's 3 and it's 4 because I'm only having a 4-core machine right now. It's my old machine. My new machine just got bricked, so I have to work on this. But eventually most of you people also having like quite a not having too much of powerful machine, and that's perfectly fine. That's not a big problem, and that's why virtual machines are also here. So I'm gonna stick with this sort of settings. You can like tweak according to yourself, maybe give some 4 GB of RAM if you can. There's no problem with that. And here like disk size, the disk size, you can leave it up to 25 gigs or maybe up to like 30 gigs. It's all up to you. So I'm gonna give it like 25 gigs as it is. So you can just leave it and just hope the finish button. It was just so easy. You don't have to do too much of it. And now it's just powering up the VM itself. So let's get power on, and I think we're gonna see a new screen where we have to perform the installation of the Ubuntu, which we already have selected, by the way. So let it get just turned on, and we'll see. Oh, it just did. It just did. So now the virtual box is showing. You can just close this button. Try install Ubuntu. You can press enter, and as soon as it started, will be I think it's not going to. Yeah, so that's it. So it's currently like stuck to this particular resolution, and I think after installation we might be able to change the resolution. You can also go to view. You can change it from here, but we'll see that It's not such a big issue right now, but let's say it get installed by itself. So let's just wait till it get installed, and meanwhile I'm gonna pause this right here so it won't be too much for long, so you guys don't have to wait unnecessary. And it's currently on the behind showing that it's running right here. There are certain settings is still up on here. So let's see. And mouse integration, let's leave it. Let's get turned on and let's see. Now it is on, and verifying the installation configuration, and it does that. It's quite simple, nothing too much of a fancy thing, but let's just get do the steps. Now there is not such steps that which we need to do right now. The only thing I think we have to do is done maybe some checking some boxes and doing next, and it's just going to be just a really standard installation, nothing too much of a fancy thing which we need to do here. And let's see, let's just wait and let's see that what it does. It's detecting, fine. Let it just create some partitions and let us just create some space for itself. Meanwhile we can wait, so let's just wait. Yeah, so it is still installing some of the files, and it's gonna take a little bit more time. Meanwhile we can wait again. So let's get completed, and as soon as get completed we're gonna see some of the installation steps for the Ubuntu to complete it. But those steps are gonna be like quite easy. There's nothing too much to do. There's like date and time and few other things which we have to set. So I think pretty much if you want to leave you can leave, but let it just get completed and we'll see. Okay, so our Ubuntu has installed, and now let's try to change here. Is it gonna do that anything? No. And let me just try to change. No, so it's been set right here. Maybe we can change it from inside. No, not gonna do the scale mode. So adjust window size. Let's see. Okay, so it's what it does. So let's try to log in and try to see that is it working or not. So change me, I think was the password, and I think we're about to get inside. Yeah, it's okay. It's just taking time because it's an old machine, so it's my bad. But yeah, we're inside. So your operating system is now running and everything seems to be fine. There is no problem with that. And let's see, we can skip this part. You can enable Ubuntu Pro if you want, but for now let's just skip. And I don't want to send any information right now because we're just having for it learning purposes. And you can enable the location services for better let's try to increase this. If you want to install any of these you can install, but like I think these some of the apps which you can use. And I think the first thing we can also check out from here is the terminal. So let's just type terminal. The terminal is getting opened. Fine. So everything is quite working, and they want you to Ubuntu English, which is our host name, and my username which I have given. So hey, our virtual machine is set up and everything is working fine. So that's for this. Let's see into the okay. So in case what happened is that when I tried to install the Ubuntu, what happened is that it didn't even ask me any sort of settings, it just installed. So in that case what happened is that we didn't get the privilege to write our own password, and it somehow just bypassed that. And in that, and if this sort of case might happen with you, what you have to do is to just go to the terminal, type the su, and over there you just have to give the password which you have given already in the while you were installing the virtual machine. And after that, all you have to do is to apt install sudo. It will install the sudo in case if sudo is not there, and if in case the sudo is not updated. So all you have to do that, and after that you just have to once it's got upgraded, nothing is to be there. And then all you have to do is to user mode ag, add the sudo. And then after your username, whatever the username you might currently have, and then all you have to do is to reboot or the restart. Either you can do it from here, or maybe you just go and do a restart. That's it. Just restart it, and hopefully afterwards we'll be able to resolve this resolution problem, if it might be happening with you, or else you didn't even need it that much. So it's now currently rebooting. You can have like do with multiple other options, and we'll try to do it, update the resolution. Let's just get restart and we'll see. So while it's restarting, let's see that will we able to change our resolution or not. So it has restarted, and let's see. Change me was the password. Bye. And hopefully we'll able to get login, and after that let's try to change the resolution, because we don't want to work in this much of a small resolution. We have like a lot of space which are getting wasted. So let's try to open now terminal, and let's see. There's this command. You're getting used to it, because I never have faced this problem but like now today it's the very first time I came across this problem. It's sudo, and there is terminal. Let's open it, and let's try to do some command thing, and we'll explain everything that what is going on here. So sudo, what sudo means I'll explain. Wait. So install, and then we have to we are working in our VirtualBox. So VirtualBox is here, and I think hopefully it's a guest account. So let's see if this is gonna work or not. Change me. Now it's working. The sudo is not taking. Okay, fine. Now I have to again see it, like what's going on. Just wait. Let's try to I don't know, maybe let's try to do this. Will it work? Okay, again, like there is problem. Okay, I have to, maybe is it guest or not? Okay, so I think let's try to exit from here. I'm gonna do Control F, and let's try to do some settings. And before that, let me just shut down my machine, and we'll see what might happen after the restart. Let's go to the setting. Let's try to change some settings regarding the display. Let's try to change it to how about this VGA, SVGA. I don't know, let's see. Maybe enabling the 3D acceleration. Invalid setting detected. This, I don't know, let's try. Will it work? That would be something crazy to see. I don't know. Let's just get boot up meanwhile. Okay, so my machine is like restarted. Let's see, it didn't change. Maybe we'll try to change it from the inside. Let's try to do that, because I remember that might also work. Change means the password, and let's try to do it from the settings, because man, like these sort of problems just arises all the time. I know you're working, and even after working so many times, like look, today I got stuck again. So let's try to change it. Was able to get the sudo privileges, but this is something which is creating some problem. Let's see. It was having some disabling here. I'm just like looking into it, like why it is there. Let's try to have a look that where is our display. Can we do it from inside? Oh, it worked fine. Oh, okay. That was something of worth noted. Okay, so display is not working. Let's see, do I have more than that? See, 14 and hopefully, yep, apply. Why it went so, bro? This is so wide. No way. Like that happened. Like how could it revert it? Keychains. Now it's working fine. Yeah. Let's see. I think it's a little bit more. And how about doing Control F? Let's try to switch. And let's see that the setting is working or not. I have to change a little bit more. And this is not working. That's a little bit more. I think this is the setting. I think it would work. Now where is the apply? Apply. Yeah, keychain. Fine, it's working. Okay. Okay. God. I was just so that was just so, noob me. I wasn't able to do. So, okay, we're inside our Ubuntu. Now it's working fully fine. A little bit slow because of my hardware, but fine, it's working. Computer name is Ubuntu English. You can even change it from here, but don't worry, don't do it. That's fine. And now everything seems to be working. Now we can even go to our terminal. We can do our task here quite easily. And hey, just look, it's working. And forget about it, that is happening because of a little bit of my slow machine, and I have like the settings done. So if I just reduce the settings to bro, don't do too much of these updates, man. Just pause. Yeah. So if I do, if I reduce it to, maybe it's not able to handle that much of resolution, but what can I do is trying to reduce it 1920 by 180. I think this might work. Keep changes. I think this is much better. The machine could now handle it easily. Yeah, you can see that is happening because my machine could not handle it, and I have like a very big monitor which was working with my gaming machine, but now gaming machine is not with me. So fine, now finally we are now able to hear. And who am I? That's now the first command. Devansh, like it seems to be working fine. So in the next video, I think we'll start it and getting into of the Linux internal, and we'll try to understand the architecture on the top level, and we'll try to start using these commands that we're familiar with. And these sort of problems, you learn it, I learn it again. It's been a while. That was such a silly mistake I was doing, but yeah, that's what it is. I don't edit my videos, so whatever the problem or whatever the things which you're seeing right here, that's what in general happens with programmers. So that's it. Let's see into the next part of the video, which I want to share an important announcement for you, which is there is a book which is pretty much like in standard notes for this entire series, and how I've structured the entire course is already being put inside in this format. So it is going to be like a very standard book, so you guys, anyone can follow it, be it like absolute beginner, experience, anyone. So I'm currently designing it in this way, and currently have been able to design, although I have structured around 4 sections, but currently I have designed these two particular sections, and we will be diving pretty much in every area regarding to the every section or every part which is being right here being presented. So which is like after virtualization, since we have done it, virtualization and installation, the remaining part is the Linux file system hierarchy. We'll see that quickly what it is, and then we'll diving into more into file system, file manipulation, and a lot of things are there. And AWS said is one of the most important part for doing manipulation things, arithmetic with strings, and all of these things will do everything. And then there is this system management is there in the section 2, in the level 2. And there could be going to be some projects, maybe for example here I put like based on L2. I haven't decided what it going to be, but maybe it could be like 2 or 3 projects. It depends on the situation, like what I fail, or maybe on the feedback what you guys can provide a feedback that what sort of projects that you might like. And it's like a growing course, so currently there are 2 levels, but hopefully there are more levels would be coming. At least there are gonna be 4, but it could increase more. There is corn and a lot of things are also there. Vagrant is also there. I think I might also explain about that. But these are the important topics also in regarding to Linux. So some of the things are like pretty standard. It's you're not even going to feel like it's just some rough notes, but these are like pretty standard way I've created, and we'll discuss. Yep. So that's for this video. Okay, so let's try to look at some of the history of Linux, because once you have a pretty good idea around like what exactly went, what happened, and how it came into existence. So what happened actually, and yeah, I'm sorry that you guys cannot see me. Like currently working on this old machine, so I have to set up my camera and it's still not working. I did try it, but we'll see. Okay, so where was I? So what happened that when Unix, there was this Unix-based operating system came into existence, and everyone started different laboratories, and they started kind of working on it together. But Linus saw it and he started doing some sort of modification. Let me show you who Linus is. This guy, he is basically the reason why you and I are working in computer science field nowadays. And he could be regarded as the father of the computer. You can, but there are like multiple people who have put their effort, their research, their life, but he's one of those who has created this wonderful, powerful piece of code, which is now being powering everything, like from cloud, from like literally whatever you're using today, your smartphone, your machine, YouTube, everything is being running on that system which he has created. And during those times when Unix was in labs, he created a code and he showed it to his few known person, maybe friends, and they be like they want to contribute. And from there, this open source, the idea of contributing, working together in a code piece came into existence, and that's somewhere Linux have started also creating one more thing which is called Git. Let me show you what that is. It's like a repo. What that repo means is actually a place where you can put your files all together. Whatever the changes is being made by you is being recorded in every uh, timestamp, whatever the date it is, whatever the time it is, you just store over it. And then there is something called, then there is like, since with Linux there is an idea also came into the contributing into code, multiple people are contributing to the same code. And when that happened, you need to know exactly that who is contributing what, who is removing what, who is adding what piece of logic into the code. So that's where the idea of Git came into existence. Git started working, and the GitHub is like a online piece of the Git, so you can share your code to anyone on the planet. Maybe in in International Space Station they can also access with an internet. So that's somewhere GitHub into came into existence nowadays. Like they're trying to automating it, but that's what this is. That's what he did. That's what Linus did. So this is the very basic history, or I was saying not just a basic, but like somewhere around the entire history of or the story of Linux and how it came into existence. Now the few other thing is could be, since we both discussed about Unix and Linux, So Unix is, as I told you, that it's been in labs. They were working on it. Universities were there, researchers were there. Linux saw that code. He worked on it, so he started creating a version of it, which is a little bit more different than like. But the core idea is coming from the Unix itself, and then there he puts few of the changes, and as you can see the open source is there. You can edit, you can even still modify today. Linux is still, I think, being contributed by people, and you can go to his GitHub where it is, like, yeah, here it is. This is his Git account. As you can see, he's still working on his Git. Okay, and there is Linux 150,000 stars that you can, he just have around like 7 repositories, and he's still working on this one. It's the main one, the Linux, and this code base is still being updated. As you can see, like, how many commits are there, just one hour ago. As you can see, he was still working. You can see that he's still working, man, on his code base. That's just different. So he's still maintaining the original code, and yeah, that's what the part of history, that's what our present is with Linux. That's for this in this video. Let's say a bye, and we'll see you in the next one. We just installed an Ubuntu, which is the Linux operating system, just in the earlier video. And I also told that is basically a Linux based operating system. So what I mean by that, so isn't Ubuntu a Linux operating system? See, there is thing called a kernel, and what kernel is, basically you can think of it like a seed in, a hard shell. So there is a seed, which a plant seed, you can think in this, you can think in this way, that there is a plant seed which consists of, everything about that, how this tree is gonna be in size, what sort of fruit it is gonna bring, what sort of leaves, its lifespan. It's like a code which is being already been sequenced in this seed. And this Linux kernel is basically responsible for everything what your operating system is going to do. So based on this seed, people, what they do is they kind of do a little bit of modifications according to their need, and they create their own operating system based on this seed, this kernel. And this is what exactly mean by a Linux based operating system. Okay, so let's try to see it from here. So a Linux distribution is basically means, as I told, that there is this sequencing of code in this kernel, and we, what we do is we kind of, modify it according to our need. For example, if someone is more focused on, scientific research and want, more scientific, uh, tools on that system that can run efficiently, so they can modify the code of the kernel in that perspective. You can also think that, for example, there are multiple cars and every car has an engine, but that engine itself has, different sort of efficiency, different sort of horsepower, according to the need of the user or the customer. So whatever the need is there, for example, a pickup truck has a like really different efficiency, but has a really high, being efficient in when it's time to pull, heavy loads, but it's gonna drink, it's gonna consume a lot of fuel. So you can think of that kernel into that way. Now, different cars, different trucks, different trees are known as, you can think of that as different flavor of the very same thing. So a plant is there, a tree is there, but trees are of different type. A tree might not, bring a fruit, a tree might bring a lot of fruit. So that's what distribution is. So same in this case of Linux, what we like, what programmers, what all of us has done is that we created, different versions of the very same Linux code, which is the kernel, and we have modified it in a way so that it can fulfill our need. You can like go on your search engine, you can try to, search like Linux distributions, and as you can see, like there are like more than 42 Linux distributions are there. Like if I just open it, like they are like, oh god, let's just look at how many are there. The Parrot OS is there. I've used it. I remember Ubuntu is there. I didn't use Bodhi, but I used like Fedora Linux also. I even have worked on Arch Linux. So and yeah, even Kubuntu. I also have like used that too. So there's so many versions of this Linux based operating systems. So we so what this kernel does, so you can think that kernel is somewhat like a program. It's like this program right here. Okay, so kernel is like a seed. So kernel is here, it's a seed. Okay, it's consists of the code, very specific code. You can modify that code. You can modify the code, and on top of this kernel there is this operating system, which is like an application that interacts with user. That means us. So that also is your Android. Even I think you can think of the iOS operating system on your Android, on your Apple devices. So Mac OS is also built on these kernels. And this operating system is actually an application under which you can run multiple applications also. Okay, it could be a server application, it could be a image editor or a image viewer, you know EDITOR image editor could be there. And what this kernel does, it sits in between in this operating system and the hardware, the physical hardware that your device has. Maybe it could be like display. For example, you say like I want to I click this image, so logically it should show you the image on the display. So OS send a signal to kernel, and kernel be like, okay, so the request is like to show an image. It also validates, see, kernel also validates that whether this request is genuine or not. Maybe it's a fake program is doing it, maybe a virus or an infection is doing in the program, maybe an unwanted program is running, so it is sending some request. So kernel also verifies that whether this is a verified signal or not. As soon as it's verified, it also does this. As soon as the verification is done, kernel sends the signal to the hardware, the display in your device. So for example, this is your computer machine right here, and here is the display. So the kernel sends this request to display, hey, I want to fetch you for a moment. I want to borrow you for a moment and to show this image on the top of the screen. And the image just showed up. So this is what kernel does. This exactly what a kernel does. This is what an Ubuntu and all these operating systems which are built on top of this kernel are there. And what they do is they went on, asked the kernel, hey kernel, can you give me this? Hey kernel, is it possible? Kernel will like, hey, let me see like whether this is possible or not. Then there are certain thing called privileges, which we're gonna see in the file system, that what these privileges are, how kernel verifies that whether a particular user is privileged or not to use a particular request or service into the system. And this is what distributions are in in Linux environment, in Linux systems, that how many versions are there. You can use it for your own, you can even create your own version for your specific need. For example, if there is a need in astrophysics lab for calculating some of the mass of the planets or the new stars, or looking into that how the impact is going to be if they started going on with the gravity pull on another planet. So those sort of calculation could be done, those sort of tools could be built in order to achieve those efficiencies. You can modify your kernel according to that. So this is what distributions are, and this is what these codes are. We'll see more of it here, and we'll try to get pretty good idea around how Linux file systems are, like why they are created, what are the problems which a file system is solving. So we'll see all those things in the next video. And that's for this video. That's what distributions are. We'll see now the file systems in the hierarchy, why the hierarchy is created, and what sort of problem the hierarchy has solved. So that's for this video. Okay. So to understand better the Linux file system, we have to do a little bit of a time travel, and we'll like to move to forward from a time period when we have some punch cards. We punch those cards which are consisting of codes, maybe some logic, and having some sort of data or information which we want to feed into the computer. And then afterwards we're also getting the output in the form of these cards. We're getting these linear outputs in like really long printable format of the lists in those paper sheets. So this is a time period when computers started getting advanced, getting advances, and they started having more and more computation power. But more on that, we will starting also getting more and more information passe, which means the data. And to handle this those amount of data, we need better system architecture to handle these sort of complexities of data, to be able to perform more and more complex queries on these data, to be able to perform a entirely different sort of logics which wouldn't be able to we wouldn't be able to do it from I think our entire history of human race. So uh, things are getting improved on the physical hardware in computer software. And more on that, since this linear way of doing computation is quite infeasible, it's not efficient, if I say. And so what we have to do is we have to improvise on a lot of levels, one of which is a file system. And by file system, it's a time period when we also the database programmers, the veteran programmers, the researchers at the big labs in the US or in the West, they started creating complex mathematical structures so that they can come up with a really optimized way of fetching the data or solving queries. So in during those period of time, there was a sort of a data structure came by, because we used to have linear way of accessing data. So the researchers, what they thought, like, what if we, instead of doing this linear searches or linear inserting and deleting, what we try to do is, how about like breaking down into half? And once we do it in half, there is some computation which will be done. So for example, if you want to find a particular number, you just compare it from the top level, and from the top level, if that value is quite on the lesser side of that level, we go on the left side and parse it on the right side. So in this manner, you're kind of eliminating a particular entire half section of searching space, or half of entirely space. So it is now getting down, every time it's getting half at every step. So this kind of started resolving such a one of the big problem, which is searching and fetching out the data or inserting. Now on the other side, what this structure also does is provide sort of a security. There was one problem started with the once the computer started getting improved on a daily basis, is that a lot of users started contributing into the same machine, which means that a lot of programmers are also doing the work on the same machine. So there is a problem started arising, which is, now since programmers, for example, if I'm programming, I'm writing a code or logic, there are highly probable chance that I'm going to use a particular variable name, or maybe particular function which might be already there in some other file. And since if there's a linear structure in the file, if there is no hierarchy, it might I might start conflicting with other code. So with earlier versions of programming languages, also C, and afterwards we started having namespaces. I think it's Fortran, I don't remember exactly, but a namespace is the same concept as file, and which is pass, if I say, is a directory also. So a file is also named as directories. And so these namespaces started resolving the problem with conflicts. And now afterwards, programming languages also try to introduce some real world logical sense of building software, which is having inheritance, hiding some sort of data so that nobody else other than specific permission could access, modify it. So these sort of things also getting reflected into the file system. So once there is a hierarchy is being created, a user is being segregated from the other file structure. So if they had to access a particular file, they have to kind of request it from the top side. It's like, you're asking your parents that, can I have this, or can I go into my friend's house? So it is up to their permission, and since you have that permission, kind of permission to live in their houses, so you can ask for certain other privileges that, hey, can I do it for a particular time period, so it may be for just one night. So it's there are two things in Linux also. So if you have multiple users, you might also starting having conflict that who might be in a control or in an authoritative position, so that they can make sure that no conflict might occur. So you can think of yourself as, you and your siblings, your cousins are there, and maybe some elder is there to make sure that everything is gone right. That if they are coming up with some sort of treats, so you're uh, dividing it equally among each other. So this is kind of way of thinking that hardware resources are there, so that no one process or one folder or one user started requiring all of the resources, the treats from which is being provided by the parent. In this case, it's a Linux kernel. So Linux kernel is kind of the controlling part, which has kind of have profound control over the entire operating system in this manner, in this hierarchical structure. And some of the problems, I think we could, now we understood that what sort of the problems which are going on and what they're trying to solve, and what this file system is solving is that no other person with no privileges or no permission should not access. There is a clear defined boundaries among other users, other processes, other folders, other files itself. And now I think we got a pretty clear picture about that, why these file system exist, how they came up with an idea of tree like structure. Tree like means the branching, why they divide it. It's just not the two division, it could be on multiple levels, but what my point is that they started dividing the code. And let's try to move to the part of try to get an idea of this announcement. Yeah, okay, so let's try to get here and let's try to see that a little bit by a pictorial representation, which I would like to do. So in earlier days, we had a file system, somewhat like the files are just being presented at a place like this, and so any process, any user can access it, which is not quite good in design. So the idea is like that, why not divide this file system into like this structure. So one a folder is there, then another file folder is here, and you might could have another file folder here. So you can have multiple file folders, and these file folders can consist of multiple files. So this is the very idea. And like then there could be certain privileges. For example, this is user 1, user 2, and user 3. So they cannot directly access this user 1 space, so they have to go through this. If this particular file structure allows it, only then they can go. And this is a very similar structure is being followed in Google Cloud Platform or any other major cloud platform, which is they just had implemented the same thing. So for example, there is your organization here, okay, and this organization you can have multiple projects which are going on. Okay, so there could be a folder for this project, and now this project could consist of multiple users which are working on a particular project, and these multiple users could combine all together, and maybe they could have multiple applications that they are working on together. So this is a very same structure which is being followed. Now there are certain file systems which are being implemented over the period of time. During 1991, when the Linux were is being being created, the prime period was also pretty similar. That at the 92, like they introduced a structure system called ext. This is a file system management, or you could say the file system type, which is means extended file system. And extend. Oh yeah, I'm right. Okay, so extended file system is there. Oh, sorry for my bad writing. Okay, so we started having these sort of file systems. It kind of, I think it has around like 2 GBs of supportive space, so that you can have a max file of size 2 GBs, which is like quite like it's a quite big number at those times. But in 92, during 91, 92, we started having quite a good amount of computation. So they started moving quickly with, I think in 93 they introduced ext2, then ext3 is there. And I think ext3 did one thing. If you remember, in old operating systems like Windows XP and maybe earlier version, I think in Windows 7 too, sometimes this occurs. Like it wasn't all the time, because it was a relatively new operating system, but sometimes it might occur that once your system got crashed, you know or CRA crashed, or maybe once the system got crashed, maybe it got turned off, or maybe something might occur, maybe the file just got corrupted, it just got shut down, and you won't be able to recover the data or the work which you have done. So in ext3, what they introduce is a kind of a log, which means it's kind of maintain a log also, that what file is being updated by the user, it also being registering those changes. The same thing you could see right here, as you can see that it was syncing. See, if I write anything, it started to sync. This is what exactly this ext3 has introduced into the cloud also, into, because cloud is the same, it's just your system, it's nothing different. Cloud is exactly the same thing as system, but it's just the case that it's being hosted somewhere in a remote place. So anything you write here is being synced all together. So this is what this log maintaining is. So it's kind of maintaining a log over there. Then there is ext4. It's quite advanced. It's, I think, kind of support, I think, 20 TBs of file system, or the file size. That would be, I think it is, but so these are some of the file systems here. And what else am I missing? Let me see. I think I pretty much have covered everything here. There's this, definitions here you could read. And did I miss something? Let me see just quite quickly. I don't remember exactly that I might be missing anything, but still, let me see through just my notes. Maybe am I missing something or not? So in next video, I'm going through my notes, but in next video we'll try to look into the internals of the how file system is being you know is there in Linux, and what other things are there. I think that's pretty much into this video. I don't remember exactly that if I'm missing something or not. And I think there is this boot thing I could also explain. Can I? Let me see, where is this, my loading thing is going on, man. What's going on? Stay here. Is it working? Yeah, it's working. It's just kept scrolling. Why? There's something going on, man. Is it still? Oh, still something is going on. Wait. Um, why it is crawling? I don't. Do you got any idea on this? Did it stop? Yeah, I think it kind of stopped. No, I think something's going on. Okay, I think that's for this video. Next video we'll try to look at boot is there, then there are etc folder is there. Oh, that's my old notes of this DSA. Wait, I have to come to this display. Something is going on with this. So next video is going to be all about these sort of problems which occurs at the behind the scenes, but I'm not gonna edit these out, because it's kind of give a really good, not just touch, but you can get you actually get a pretty good idea about where how these things are being getting recorded, what sort of problems are there. So this is you see, uh, I don't know where this is going now. I'm not gonna even open that my node. So these are the problems. But in next video we'll try to get an idea about the file structure, what other files there, and how the conflict is being resolved. Privileges are there, a concept of privilege which is being introduced in Linux, and there is a concept called a pseudo user, which means exactly like a super user is, it's super user, and sudo is like taking some of the powers from that super user. Hey, super user, can you give me certain powers for a while so that I can work on this particular thing that which I am trying to do. And super user be like, yeah, okay, fine, if you have the proper credentials. So you can think this example, I just remembered it. You can think this example in a way that if you're trying to install Windows operating system, what is there is you need to put a particular credential so that it's started to getting become executable, and you started getting those privileges. Hey, yeah, okay, so you can work. Okay, so I remember something. There is something also called in file system. In this files is that there are certain thing called XRW, or maybe one of the flags. These flags actually have the operating system to determine what sort of privileges a file have, or what sort of privileges a person might could have. So for example, there is X flag which is being there. I'll show you, and that X actually means executable, that whether this file have the privileges to execute in the system or not. Then there is write privileges, that whether the file is being able to being written by a user or not, or just, or if it might could be just a readable file. Okay, if you just remove the readable read flag, so it just might remain, you might be just set the X flag, which means executable, and the write privilege is W and not the read, so nobody can read it what's inside there, but you can execute and write with the help of this file. So these are certain things we'll see into the next video. We'll try to I'm looking at my notes. So there are these folder structures we'll see, and I think that's for this video.